So good evening, my dear students. Today again we are having a new video. We are going to start new topic today, new chapter, which is your electrochemistry. Okay. So in this chapter, what is the importance of this chapter and everything we will discuss. So if we are talking about this electrochemistry, so it will consist one question in JEE mains exam and two question in NEET UG. Okay, so two this time it may be increases two or three, so we can consider it 2 to 3 question from the electrochemistry in our NEET exam. Okay, so and it is a part of what? Physical chemistry. It's a part of physical chemistry, children, and we are going to discuss about this topic today. So this is our topic, and here night light. Wait. So this is the concept of the chapter, physical chemistry, and one question in mains exam, 2 to 3 question in NEET exam. That is the chapter. That is the number of question. So we'll focus on it. We'll start with electrochemistry, and if you will be with me, so your all doubts related to physical chemistry will be cleared. So basically, here one question, JEE mains, two or three question in NEET UG program, UG exam. So electro means what? Something related to electro means electricity, and chemistry means if chemistry is involved in the electricity, then it's called electrochemistry, chemical reaction. So we are going to discuss about electricity and chemical reaction related topics. So what are the topics in this chapter? That we have to discuss, focus on this. So the topics are, first we have to discuss about the electrochemical cell. Electrochemical cell. So that you can say galvanic cell, or you can say voltaic cell. What is the work of this cell, children? Basically, this electrochemical cell convert chemical energy into electrical energy. Second topic is reduction potential. Third topic of the chapter, Nast equation. Number 4, electrolytic cell. Electrolytic cell, that means electrical current, electrical energy into chemical reaction. Number 5, Faraday's law. And number 6, conductance term. So these are the topics of this chapter. conductance topics related to electrolyte. So this is the content of this chapter. These topics we have to discuss. Total 6 topics in this chapter we are going to discuss. Okay, so hope it is clear to you. What clear? It's a simple thing, only topics we discuss. Now I am erasing. So here children, why this electrochemical cell concept developed? What is the basic thing behind the electrochemical cell? So children, one experiment performed what is the experiment? Electrochemical cell based upon one experiment. Someone performed one experiment, and what is the experiment? Here one container, vessel you can say. In this vessel we are pouring copper sulfate solution, CuSO4 solution. What is the color of CuSO4 solution? Aqueous, and this is blue in color. Okay, then in this solution we are placing one zinc metal rod. And here one thermometer we are placed. Okay, so this is the thermometer. So this kind of setup is there: copper sulfate solution, thermometer, and one zinc rod. After some time, leave this for some time. So after some time, some observation came. What are the observation? First observation came: zinc rod reduced in weight. Zinc rod reduces in weight. Zinc rod reduces in weight. Second observation: blue color disappeared. Copper sulfate solution, blue color disappeared. Third result was red PPT formed. And fourth was temperature increases. So these are the 4 observations. So why these observations came, children? Because some internal reaction happened. So what process happened inside? Zinc rod reduces in weight. This weight finished. So what happened in the zinc? Zinc solid state to converted into zinc aqueous. Zinc ion came in the solution and it reduces 2 electron. Which process it is? Oxidation. Yes or no? Here oxidation number 0, here oxidation number +2, oxidation number increases. Oxidation. What about copper? Copper solution is there, CuSO4. So Cu +2 ion accept these 2 electron and converted into copper solid. Here what happened? Reduction. So in the container, oxidation and reduction happened, and without any external help, so it is a spontaneous reaction. So what happened here? Direct redox reactions happen on same container. So you can write note here. Direct redox reaction happen on same container. And which kind of redox reaction? Spontaneous redox reaction. And spontaneous and everything you can go through the thermodynamics lecture, you will get without any external help. This will happens. So the thing is, children, blue color disappeared because copper ions are coming in the solution. Solid copper formed, then because that is why red PPT formed, and temperature also increases. So that means we can utilize this temperature in useful way. Temperature means energy of the system, energy of the container increases. So that means during this process, chemical reaction happen. That means chemical energy convert into heat energy. Convert into heat energy. Chemical energy converted into heat energy. That means during the process, energy released. And energy released in the form of heat. So from here, the concept of electrochemical cell came. From the chemical reaction, if energy released, that energy we can use for useful point of view. So that is the basis of behind the electrochemical cell. That is the logic. So now today we will finish this electrochemical cell, and it will be very easy, children. Be with me. I promise you, you never forget the concept. Electrochemical cell, or you can say galvanic cell or voltaic cell. Electrochemical cell, or you can say galvanic cell. At the same time, you can say spelling you can manage. Concept will be clear, but I'm not sure about the spelling sometime. So what is the main concept? Electrochemical cell is a device which convert chemical energy into electrical energy. It's a device which convert chemical energy into electrical energy. Electrochemical cell is a device which converts chemical energy into electrical energy due to redox reaction. Due to redox reaction and spontaneous redox reaction. So that means spontaneous redox reaction means delta G is less than 0, Gibbs free energy change should be less than 0, that you can go through the thermodynamics Gibbs free energy concept. It is available. I will provide you the link for this Gibbs free energy change in the description. You can go through it once. Okay, so if we are talk about the examples, so there are so many example for electrochemical cell, remote cell, your remote TV remote, whatever remote you are using, watch cell, wrist watches or wall clock, nickel silver cell, nickel silver cell, chromium lead cell, and whatever in our syllabus that we are going to discuss now. In our syllabus, the cell is zinc copper cell, zinc copper cell, zinc copper cell. It's called Daniel cell. So it is in our syllabus. We will construct this zinc copper cell, Daniel cell, and discuss the all parts of this electrochemical cell. Okay, so for this we have to take two container. Okay, in these two container, one container it is filled with zinc sulfate, ZnSO4 aqueous solution. In the second container, CuSO4 aqueous solution. Then we have to place in zinc container zinc rod, in CuSO4 container copper rod. Okay, and attach this with a wire connected with voltmeter or ammeter to notice the flow of current, direction of current. So that is the setup, children. It is not complete. Okay, so I will explain the process first. So what happened, children? In that case, redox reaction happened. Here zinc ion, Zn+2 ion coming in the solution from the rod. If positive ion coming in the solution, then negative charge density, negative means electron increases in the rod. What's happening here in copper sulfate solution, CuSO4 solution? How many ions you are having? Here Cu+2 ion sticking on the rod, Cu+2 ion sticking on the rod. Then what happened? Positive charge density on the rod increases. So from here electron start traveling in this direction, blue line, and then flow of current, that is your ammeter, flow of current started in opposite direction of electron. That is the direction of current. So in this solution, positive charge Zn+2, this solution is positive charge solution, and here SO4 ion, SO4-2 ion concentration increases. So this solution is negative solution. So here children, this where oxidation and where reduction happened, that easily you can identify. Check it how. Zinc reduces into zinc aqueous, solid to aqueous, plus 2 electron. That means what happened here? Oxidation. In the case of copper accepting 2 electron and converted into copper solid. Here reduction. Okay. So here oxidation and redox, that means oxidation and reduction, that means redox reaction happened. In that case, this zinc, this reaction is called oxidation half cell. Oxidation half cell, or you can say left half cell, or you can say negative half cell. For this reduction, here you can say right half cell, reduction half cell, negative half cell, cathode half cell, and here also it's called anode half cell. Okay, so here anode, what is the charge on this anode? Tell me. Negative charge. Here copper, positive charge. So you can learn one short trick, always lone for electrochemical cell. Lone. Lone is what? Loan, that is not loan that bank or something else. Loan means left. Always left side oxidation. Left oxidation, that cell will be anode and charge will be negative. That is the concept of loan. But here one problem came, children. What problem? When this flow of electron stop, that means when complete Zn charge came here in the solution, then flow of electron stop and flow of current also stop. So that cell is not worthy, means once you start using and after 5 minutes, 10 minutes, that will stop working. To remove this problem, we have to use salt bridge. Here we have to use salt bridge. In salt bridge, filled with inert electrolyte KCl. So here negative charge density increases in this copper container. So here flow of K plus, and here negative charge density increases, positive charge density, then Cl minus ion. It will neutralize and flow of current again started. That is why your remote cell, your watch cell working long time. Sometimes they work will 6 months, 8 months, years they are working. So because of this salt bridge. So this is the complete construction of zinc copper cell. Any confusion you can ask. Once again I will repeat. Electrochemical cell, what children? It is a device which converts chemical energy into electrical energy due to redox reaction. Spontaneous redox, that means delta G less than 0. Remote cell, watch cell, nickel silver cell, chromium lead cell. In our syllabus, this cell is there, zinc copper cell. In one container, zinc solution, zinc rod. Second container, copper sulfate solution, copper rod. Positive ion, zinc positive ion coming in the solution, then negative charge increases, electron increases on the rod, and electron start traveling from zinc rod to copper rod, because copper in this rod, positive charge Cu plus 2 ion is sticking on the rod, positive charge increases on the copper rod, and flow of electron started, then flow of current also started. But to maintain the electrical neutrality, we will use salt bridge. That's why our cell is working longer. Okay, so this is the complete construction of cell, and this salt trick also I told you, lone, left oxidation, anode negative. Hope it is clear. Now I am erasing it. So here left half cell, some points are there, children. Point number 1, left half cell. Left half cell, positive charge, because in the solution positive plus 2 ion coming, positive charge solution prevents outward flow of electron. Prevents outward flow of electron. Second point, right half cell negative charge solution, because SO4 ions in the solution prevent inward flow of electron. Then problem happened. So remove this problem. So for maintain electrical neutrality, we have to use salt bridge. What happened, children? Positive charge in the solution, negative charge on the rod. So what they will do? They prevent the outward flow of electron. Similarly, negative charge in the solution, positive charge on the rod. So that will prevent the inward flow of electron. So for maintain electrical neutrality, we have to use salt bridge. What is salt bridge? Now discuss about the salt bridge. Basically, salt bridge is a U-shaped tube. It's a U-shaped tube. Okay, inverted U tube. What it is? You can say inverted U tube glass. In this rod, we have to fill inert electrolyte. Cl minus came this side, K plus came this side. It is filled with electrolyte, and electrolyte should be inert. Inert electrolyte means it should not be react with ion present in the solution. You can use KCl, you can use K2SO4, you can use KNO3, you can use NH4Cl, etc. But in our book KCl is given. With directly it is not used. That electrolyte is used in agar powder, or in that place you can use gelatin also. In semi liquid state, in semi liquid state, basically this agar powder or gelatin, the work of this to make the solution slippery, slippery easily they can coming in the solution. That is why this agar powder or gelatin is used. Okay, so function of salt bridge and remaining thing we will complete in the next video. So almost half an hour completed, and this is the first lecture of thermodynamics. So please watch the video and again share the video. Thank you, children.